Oh, on the video note, I got an email Friday that they'll be able, even though I emailed her and the woman who's supposed to provide me with the editing software hasn't gotten back to me as of this morning, about an hour ago, that hopefully by sometime this week, I will have online somewhere, hopefully, all the videos that I've shot so far. You can see Dr. White Productions of Chem 1212. All right, can I have everybody's attention? Everybody, take a deep breath, let it out, take a deep breath, let it out, you're all nice and relaxed. All right, I'm going to talk about the first really challenging reaction with alcohols. We've already gone through how to name them, how to make one, and this is the dehydration of alcohols to alkenes double bond. Now, listen carefully. This is one of the more challenging reactions you will have this semester. Relax, you can manage it. At first you'll see what's going on, but eventually you'll get the hang of it. But yes, this is a little challenging, but you'll get the hang of it. All right, if you take a double bond, you take an alcohol, react it with sulfuric acid, which is H+, and the little triangle means heat, you know, a little flammable Bunsen burner. And 180 tells you it's really hot. And you're going to be doing this tomorrow or Thursday in the lab, dehydration. You get a double bond. Now, the double bond, where the hydrogen is and the type of molecule, you might have two possible products. And I'll show this on the board in a second. And another great Russian organic chemist, there's a number of them, a number of German and American too, but I'll get to them also, named Zaitsev, came up with a rule. Do not write down Zaitsev's rule. Trust me, I'm a organic chemist. All right, Zaitsev's rule says, this reaction follows Zaitsev's rule. The major product in intermolecular alcohol dehydration reaction is the alkene that has the greatest number of alkyl groups attached to carbon atoms with double bond. What? Relax. Let me show you how to remember Zaitsev's rule. The key thing here is you have to know how to count up to, I think it's 4. Fine. Let's take a look at this reaction. The first thing you should be doing is asking yourself, what's different? Oh, by the way, I forgot to mention something very important about the test, number 1, and your grade. Because the lowest test is drop, if that's your lowest test, everybody in here still has a chance to get an A in my class. Some of you might have a little more challenging route than others, but you all do. All right, let's get back to this. Look at a molecule. What's different? What's not carbon? What's not oxygen with a hydroxy group on it? On a carbon, alcohol. What are we reacting with? Sulfuric acid at high heat. What happens? And you have an alcohol, carbon with a hydroxy group, adjacent carbon, one next to bond to this carbon with a hydrogen. You lose OH, water, and you form a double bond and follow Zaitsev's rule, Z's rule. Well, what's Z's rule? Well, we look at this molecule, and look out, I'm going technicolor. I just did a generation gap thing on you people. But anyways, if you look at the molecule, the hydroxyl group carbon is attached to carbon here, A, or this carbon, B, and both have hydrogens. If I follow the reaction where I lose this hydrogen and this hydroxyl group, I don't break carbon-carbon single bonds, 4 carbons, And between these two carbons, HOH, are form a double bond. I'll call that product A. Now, what happens if I lose the hydrogen here and the hydroxyl group? I'll form a double bond between these two carbons.
Sorry, I missed that.
Again, I don't break carbon-carbon single bonds. Here are the two carbons, I'm forming a double bond. And where Zayseth's rule comes into play, it tells you what's the major product. Now listen carefully. If you go on the internet and look this up, they'll show you this reaction and say, one's the major, one's the minor. In my class, I'm going to make it easier for you and just say, the one that's predicted to be the major one by Zayseth's rule is the only product you get. And that will make your life a little easier, but it'll make it easier. All right, well, how do you determine which one is favored by Zayseth's rule? Don't know. Well, you count the carbon atoms. Listen carefully. You count the carbon atoms directly bonded to the carbons of the double bond. Well, if we look at here are two carbons of double bond, what carbon atoms, not groups, atoms are directly bonded? That one. If we go to B, here are two carbons of double bond. What carbons are bonded, carbon atoms, to the carbons of the double bond? Now you have to use your high-level math skills and count circles. This has one, this has two. Hopefully I did that right. Yeah. Now, which is the larger number? Time's up, hopefully all 2. Therefore, this is the correct product. The way I'm teaching it, it'll be the major product, but for my test, that's the product you put down. That's how you apply Zayseth's rule. You get the double bond, the alkene, that has the most carbon atoms, and that's the key thing, not groups, atoms attached directly to the carbons of the double bond. I'm going to help you out. What would be the product of products? And then we'll apply Zayseth's rule that you could get if you lose the hydroxyl group and the hydrogen from A, and if you lose the hydroxyl group and the hydrogen from B. Why don't you try writing those two products down? Like I said, this is one of the more challenging reactions. There are about 5 of them. This is the first one, probably one of the most challenging of all. I neglected to say on test number 1, the highest score was 105. Oh, and for tomorrow's lab, I'd wear a top that comes up to around here because you don't want any exposed skin. That's for your safety. Not that I'm approved, I'm not. All right, let's take a look at this. And Zays's rule, or just the reaction in general, what's different? Hydroxyl group on a carbon, adjacent carbon has a hydrogen, sulfuric acid at high heat. In other words, you heat the heck out of it, which we'll be doing tomorrow or Thursday, and you get a double bond, and it follows Zays's rule. And I honor his great achievement, which is his, by using his name. That's something organic chemists do. If I lose the hydrogen from A in the hydroxyl group, I'll form this 1, 2, 3, 4, 5, 6 across. If I lose the hydrogen from here in the hydroxyl group, I'll form the following double bond or molecule. You think we'll see that now? All right. Now, which one is the correct product? We have to apply Zays's rule and count how many carbon atoms are directly bonded, and the key is atoms, to the carbon's double bond. 1, 2, 3. This one, what's directly bonded to these two carbons? 1, 2. You don't count the rest of them. That's a common mistake. So if you look at A and B, how many circles does A have? 3. How many does B have? 2. Which is the higher number? 3. That's the product you get following Zays's rule. And that's how it works. And it does work. We'll do a couple more. There's some in the problem set. But the key thing of Zays's rule is to count how many carbon atoms are directly bonded to the carbons of the double bond. And the one with the higher number is the one you get. What happens when they're both the same? We get a 50-50 mixture vote. That will never be on my test. Yeah.
So you said it's the most carbon atoms directly bonded
To the carbon atoms of the double bond.
to get to your...
That's the product you get. All right. Real easy one that I'll cover tomorrow, but we'll end up with this. You take an alcohol reactor with HX, you can replace the hydroxyl group with a halogen. I'll explain why tomorrow. Let's see, I don't have enough time. I'm going to let you out early because it's President's Day and it's sunny out. And I hope you got out yesterday. I started walking yesterday and Saturday. Remember, people, lab tomorrow. Wear a long sleeve top or bring a lab coat. Make sure your top covers up to here. Tell me how
carbon atoms that are attached with it. So if you look here,
You're not the first, that's what other students do. But you came in late.
I don't know how you grade it, but for this one, I just got this.
All right.
It's my sister. She plays for softball and then their tournament every year. And every year. This is her last year. So, yeah. She's like,
So maybe it's a couple days like that.
yeah, so then Wednesday. Oh, yeah. Oh, his license.
Two-thirds of the class. Something different if I can help you out.
So like when you go to basically things in the hospital, but in South Africa they have yeah, everybody comes, and then in Italy they have
Ran out of time, we're burned out, and you can still get the class, but you gotta do something.
kind of, but that's more of like a social thing, like everybody in the like
You gotta just-
the
One
town
of the things
comes
you might
to see,
consider is
well, in
they have peer tutoring here.
yeah, it's, yeah.
And through the school, if you can't figure out how to get to
Yes,
that,
it's
you
more
know,
like private.
how to do that, try never, but peer tutoring, and I believe one of the students who's already using it this semester said one of my former students is one of the two of them are the peer students, so it's helping them. That's right.
So are you taking good notes?